All right. Hello, Dr. Miko and rest of the class, if this is going to be broadcasted. My name is Matt Locknane, and I am going to present my final project for MBA 505 today. And what I decided to do um, is actually, being in quarantine and, being a GA, I don't really have a job right now, so I decided to almost formulate a make-believe bread company from the comfort of my home. So what I did was created the company, kind of identified four parts that I wanted to, or four things I wanted to accomplish in doing so, and I'm going to show you my results here. So the first thing I did was create an income analysis for the company. Looking online, I decided that I was going to create a company that made three types of bread. So I looked up the recipes, looked up, what I would need for each bread, and I created an income analysis for each recipe that filtered into, sorry about that, into a summary section for the income analysis. And all this is, linked. So if I go in here, if I type 100, that updates the rest of my analysis. So kept it at 0 to start. Let's put 100 in here. Let's say I make 100 of each bread. This is going to give me, a net income of $436.75. So this analysis, it's all interactive. It takes the price of ingredient for what I found on the internet and incorporates it into a model that gives a revenue per product, a variable cost per product, and a fixed cost per month. Being at home, I'm not, I mentioned in my report, I'm not paying rent, but to make this kind of a realistic scenario in formulating a business, I decided to include, rent and your main utilities involved in making bread. You're going to need water, you're going to need to pay a gas bill, electricity, and so my fixed costs they came to 1827.25. The next part that I did was actually breaking even analysis. So using this income analysis, I first set everything back to 0. So 0, 0, and 0. And if I set everything to 0 over here and did a break-even analysis using GoalSeek, I'm going to be able to break even by making 241.38 units of whole wheat bread with everything else at 0, 297.6 units of sourdough bread with everything at 0, and then 204.62 units of pita bread with everything at 0. So, making these at 0 again, I also created a data table, well, 3 data tables to visualize that. The red indicates that, you know, this is the total income I'm making for units sold per bread. So if everything is at 0, if production levels are at 0, and I just wanted to make whole wheat bread, um, I would have to make, what was it, 241.38 units, so 242 units to break even. And that's what each of these really signify with the green, visualizing that point of which we break even. I thought this would be helpful because, during a quarantine time, trying to run a business, not only are production levels limited, but the ingredients that you find and the ingredients that are available each week may vary. So some weeks you may only be able to make whole wheat bread, some maybe only sourdough bread. If you can't find sourdough starter, maybe you resort to pita bread. So that's the break-even analysis for each individual product. In part 3, I attempted to and this is a lot here, I attempted to find the break-even point for product mix. So first here, this first section here, and we won't get too into it, I created three data tables looking at units sold, product revenue, product variable cost, to try and find a product profit margin, excluding fixed costs. So, where my fixed costs over here are going to relate to, I'm going to have to pay this no matter if I make one, if I make two recipes, or if I make all three, I'm going to have to pay that fixed costs regardless. So, put it here, created a data table. This gives me the product profit margin, for each recipe, and then I graphed it in this first graph here. So this says that this is the product A profit margin, this is the projection, this is the product C, and product B down here. So each of them have a different proportion of proportionate projection of where their profit margin is going to take them. I intentionally, in making the model, I made whole wheat bread costs, I think, $10, and sourdough bread, being that it's a little bit, more costly to produce, it's going to run $18. And pita, I just put it in the middle. I said 12. So if I was going to sell my bread at the prices I established, with the profit margins that therefore came about because of how much it costs to make the bread and how much I decided to sell for it, this is the graph I created. This doesn't really answer my question though. So what I actually did was try and visualize um, a product mix, a multiple product break even point. Was I actually took the profit margin from each and I just made one simpler data table over here, and then I added red across to find a sum of margins per equal number of products produced. So if we produce products in parallel, regardless of trying to maximize profit, this is what it would cost. So if we took one of each, I'm going to make 22.64 excluding fixed costs. So I took this table down here and I made this graph that's included in my report. So where red is the fixed cost line and each projection accounts for variable costs, my break-even points for each product are actually going to occur whenever my projections cross that fixed cost line at 18.27.25. So these are the numbers we established earlier in the individual product break-even analysis. Now, in this table down here, I looked at, when's the first, when is the first instance where I either break even or go over even producing the same amount of units, and that's going to be at 81 units per product A, per product B, per product C. So I make 81 units of each product. I'm gonna break even, and I'm actually gonna go a little over break even, and that's what this number signifies here. So I went and I actually graphed that. So with equal unit production, my break-even points are going to be here. So what this really says is, whenever you're creating a a break-even point for a multi-product mix, you're actually going to have multiple break-even points because you can make 81, 81, 81 and break even. You can also do 79 on here, 81 here, and 82 here. You're also going to break even. So there's a relationship here. I tried to play around with the combination permutation tool in Excel, but wasn't really able to find something that I could visualize for this report. So I made this graph here, and this pretty much says that at this point, any point on this line combined with any point on this line and any point on this line in between here is going to get us over that break-even point. This is that break-even point in a sense, but that's also not the only way to break even. Where if let's say we required one product to be made of each, we could do one of product C and then 81 and perhaps 40 of product B and product C, and we could still break even. So I see I'm almost at 10 minutes now. I'll real quick get into part 4. I used Excel Solver to try and maximize my profit by maximizing my working hours, and I did a couple of different variations here. I actually had some issues because I found that Solver doesn't really incorporate, or at least not to my knowledge of or my expertise of using Excel, doesn't incorporate that process element to the manufacturing process, where it assumes that almost in a Gantt chart structure, one happens after the other, perhaps a proportion. Um, Bread making, it's something where I really only have to work during my prep phase, and let sit, cook, and cooling time. The bread's just sitting there. So my first Excel solver I actually put 240 in for each. So it's saying, like I said in my report, 240 hours per prep, per let sit, per cook, per cooling time. It maximized my profit at 143,020 by producing 240 units of pita bread. And looking back at this, if this is my profit margin, and we go back, pita bread, being that it doesn't have to rise, actually takes the lowest time to um, to make. That in essence, although inaccurate because of hours, this is a correct idea from Solver. Whereas you know selecting the product that's going to give me the highest profit margin and the lowest time to make is going to maximize my profit. My attempt 2, 3, and 4, I was playing around with it, trying to get something a little bit more accurate, but I realized I almost had to create a Gantt chart myself for this. So whereas this first table up here illustrates what Excel Solver did, um, it really created the maximization based on proportion. So if we have 240 hours of cooling time, come back over here, 240 hours of cooling time, we're going to have 60 of cooking time, 60 of let sit time, and 120 of prep time. And it's pretty much proportion saying, we can make one loaf of bread per hour. Like I said earlier with the Gantt chart, I had to play around with this, but prep time being a half hour, in green, I could do a prep time every half hour on the half hour. So it's really a perfect proportion. Did that unintentionally, but it turned out to work out well. Where my my max production and max profit were 408 units at 240 hours. So that is my product maximization and profit maximization and production maximization. One thing I found with that Excel solver is that it also doesn't account for production time, um, or process in terms of production time. So that's something that we had to do manually. All right, I see I'm over my 10 minutes now. Apologize about that, but that's my project and illustrated the main aspects in my report. Thanks.